Okay, this is just a quick video about rapid prototyping and watchmaking. A lot of people ask me, will 3D, with the prevalence of 3D printing, is it possible to, make part X or part Y or so on? And the answer is actually yes and no. So a lot of the limitations with 3D printing are really around how small you can make things. So while a lot of people are interested in how large you can make things with 3D printing, as in, you can make houses or roads or whatever, with watchmaking, really you're thinking about how small you can make it. So desktop type 3D printers, the most commonly seen styles around, like the MakerBots, Printerbot, RepRap or what have you, the general quality that comes out of those machines is fairly bad. So if you've got an item that's fairly large, they look okay, but if you're doing something that's small, you're very limited dimensionally and also quality-wise as to what you can do. At the end of the day, if you've got any details smaller than about 0.5 of a mil, they're probably not going to turn out that well. So if you're designing any sorts of parts, particularly for watchmaking, and you're looking at doing it on an FDM type process, which is fused deposition modelling, which is the filament type stuff that's melted in a tube and squirted out, like you most commonly see, then you really got to have realistic expectations about what you can actually make. So today I'm just going to show a success story, and just bear in mind as well that this is really pushing the limits of what you can do with desktop 3D printing, because it's the stuff that you can make small is actually most stuff you just can't do. But this sort of stuff, which is what you see there, oops, let's just escape there. So what you see there is actually a battery carrier for this watch here. Actually, I'll show you the watch first because that's much more interesting. So this is one of the very early LCD watches that SEIKO made. I'm just looking on the back there, it's a A039, so that means that it's an alarm watch. I'm just having a look at the front there. They've got quite a large LCD display, and the cases on these are thick, they're huge. So you'll see there it's quite a fat case. Now they've got two front buttons there. That one is actually the light when you're not in any mode, and that one shows you the date. Now this one here, it changes the mode, so you can go from, there we go, so you can go from timer, which I think is, yeah, I can't remember what you can do with that, but I think it's a countdown timer or something. There's the alarm, which you can set, which I'm not going to set right now, and there's auto, and I don't remember what that does. And then we go back to standard time. So these came out in 1977, and they're actually a multiple part case. So that whole section there that comes across along there, that's one section. That block there that the crystal sits inside and the buttons are in, the front buttons, that's another section. And then underneath there's another plate as well. So I'm not going to take it off because this watch is finished and I don't really want to disturb it, but that little this little plate on the bottom comes off, and it's a monocoque case, and you drop the movement in, and then you drop the glass in, and then there's this sort of outer shell clips on, so they're quite a complex case overall. Another thing with these, which I don't particularly like, is you can never get the dials to sit straight, and that's something that was an oversight at SEIKO at the time for some reason. And you can see there the text is just slightly off. Every one of these I've worked on has had a wonky dial, but it's just what that is what it is. When they came out, they were completely groundbreaking, state-of-the-art technology. They come in a really good bracelet, so that's it there, and It's that sort of clasp style bracelet, which you didn't really see too much of until the early 80s really, so that was a few years ahead of its time. The battery's got a hatch on the back, which makes life a little bit easier when you need to replace it. But it does open the battery, well, opens the movement overall to more water ingress, which is actually what happened with this one. So I've got some future photos which I'll put up at some point, which show how much actual damage it had, but I had to do a fair bit of track repair on the module in there. Of course, the modules are long since unavailable, so that let's put it back to the second counting there. So yeah, the modules are long since unavailable, so it's very difficult to get them. So I ended up actually replacing a number of the tracks with some brass strip and soldered those on, and that got it going again and fixed all the acid damage. But one thing that the acid does in these watches is they have a plastic battery carrier, which is that guy there. Now there is a part of that missing, which is a tang that comes out in that gap there, which the battery sits down on and then presses onto the circuit underneath. I've got some photos of how that works as well, but I'll see if I can sneak them into this video, but I'll put those up on the website at a later point. Now, one problem with this plastic is it's heavily affected by acid. So you'll see there, parts actually in multiple pieces. So completely ineffective for holding the battery onto the movement. Now, what I've done here is I've actually stuck it onto some masking tape, so I can take some measurements off it and then do a design and recreate the part, which creates some problems because this part's actually quite small. If I just get a pen, I'll show you how small it is. So that's pen there, and that is the part. So generally that sort of size part is really pushing the boundaries for FDM. Actually, I'll just get one of these guys here, and I'll take a just give you some rough measurements of how big it actually is. One tip with vernier calipers: if they're under $50, don't buy them. So the $10 cheapies from China, they actually give measurements that are anywhere up to 0.2 to 0.3 of a mil off, sometimes even more. And if you're doing any sort of precision work, that's no good. So we'll just measure that there. So on the long side, we've got around 17 mil. On the short side, it's about 13.2, so it's a fairly small part. But anyway, we managed to conquer it. And what we've done here is, this is a FDM 3D printed part. If it ever comes into focus, I might actually hold it with some tweezers. Right, that should help. Okay, there we go. So you'll see there it's slightly changed just to make the 3D printing simpler. So it's not exactly the same as the original part, but it's functionally the same, which is the important part. And that's just designed as pretty much a direct drop-in for the original component. A little bit of hand fitting had to go with this as well. Reason being, just around those corners there, that's any thinner than that, and you're going to get an open hole, which is it's not really going to affect the part too much, but from a quality point of view, it's not that good. So I've made those parts a lot fatter than they need to be, and I've actually filed them back with a file just to the shape that they need to be. Which, if you have a go at this part, and I've actually uploaded it onto Thingiverse, so people can play with it or give it a go themselves or do whatever they want. If you have a play with this part, you definitely need to do some hand fitting. So the underside of the part, one of the other problems with 3D printing is you have to have one flat side. And in the case of this part, there's actually a little channel that goes under that section right there, which is basically impossible to put in with 3D printing. So after I finished the part, I actually filed a channel in there and then plastic welded the battery tang to go in. which worked really well actually, and the fact that the watch is working is testament that that's going to work out. But yeah, this is really pushing the sort of limits of what you can do with 3D printing. So if you're talking about making dials with it, it's not going to happen. If you're talking about making bezels, not going to happen. That the finish is just nowhere near, and you may pick that up on the camera, but the surface finish is actually reasonably rough. And with the current processes of 3D printing, that's not going to get a lot better. There are new resin machines coming out that are more cost effective, and that will change the state of play a fair bit. But they're all still in development, not mature and all that sort of stuff at the moment. So at the moment, this is pretty much where it is. So yeah, even making crowns and stuff, people have asked me to make crowns, and I can only produce stuff like this basically. So in the future, that will probably change. Sintering processes are getting a lot better, but even with sintering, you'll need to do finishing afterwards as well. So you'll sinter the basic shape of the part, and then you'll have to machine in all the precision edges and all that sort of stuff. So traditional machining is going to be with us for a long time yet, but 3D printing and rapid prototyping does make some things a lot easier, and this is the sort of job that it's suitable for, and yeah, barely suitable. So so yeah, that's where that's at, and I'll finish this video off here, and feel free to subscribe. I'll try to put up videos more often, and give you a bit more of an insight into what I actually get up to here. Alright, thanks for watching, and I'll have another one up soon.